We saw the two types of organic compounds. Now we are using organic compounds in daily life. We are wearing clothes also, which are also made from cotton fiber. Now that cotton fiber or any synthetic fiber gets dirty, right? Now if it gets dirty, what do? You give it for cleaning. That means the washing of clothes is necessary. What happens when I add detergent powder in the water? You will put detergent powder in water, make nice foam in it, put the clothes in it, and in the advertisement it comes out that it is clean. It's not so easy to clean clothes like that. Only in the advertisement it is possible. What are actually soaps and detergent doing there? We are going to learn what is the role of soap and detergent. Now soap, when I am saying, not the soap which we use for cleaning our body or for bathing. Here I am only concentrating first on washing of clothes. The soaps, the small soaps which are available, which we are using for rubbing it over the collars or the dirty part and then brushing it, those soap I am telling you about. And detergent means the powder which we are putting in the water, making a foam, soaking the clothes in it, and after some time washing it. Both are cleansing agent. So we are going to learn about soaps and detergents. What are they? They are cleansing agents. Now what is cleansing? Cleansing means cleaning. Cleaning of anything. Now I can say soap which we are using for bathing is also cleaning our body. Here cleansing agents means the agents or the things which we are using for cleaning purpose. Now here we are concentrating first on how do they react with water. How do they react with the dirt in our clothes. Now when we wear clothes, we go out in sun, we sweat a lot, right? Now this sweat attracts lot of dirt, and that dirt gets accumulated on your clothes, especially the collars, the cuffs, and the clothes which are actually touching the floor. So those get dirty very fast. So how to clean it? You must have seen at home that we are rubbing it with the brush, we are applying soap, we are putting in the foam, or we are soaking it for a long time. Actually what happens? Now a soap molecule is formed. You take a handful of powder and put it in water. You make a nice foam out of it. There number of molecules of soap are formed. Now soap molecule, what does it contain? I'll show you. Soap molecule, what does it contain? It is a tadpole shaped molecule. Have you seen a tadpole? Tadpole is a first stage of formation from which comes out from the eggs of the fish. It looks like something like this. Okay, that means it has a head and a tail. The soap molecule also looks like that. It is having one head which is called as polar end, and this end is called as non-polar end. This end, polar end, is made up of sodium or potassium salts. So we can say the polar end can be sodium or potassium ions. Okay, and non-polar end is organic part. It is having an organic part of the soap molecule. But what is a soap? I have told you about the soap molecule. Soap molecule has somewhat this shape which is formed in the water. But what is soap? Now soap or detergent is sodium salt of fatty acid. Is sodium salt of fatty acid. Sodium or potassium salt of fatty acid. Now in the definition only you can say soap is sodium or potassium salt of fatty acid. I showed you in the structure. One end which is having a sort of head shape it is a polar end which is containing the sodium ion or potassium ion. That means sodium or potassium salt. And the other end is a non-polar end, that means it is the end of fatty acid or the organic part of the soap molecule. Now this is the soap molecule. This end is also called as hydrophilic end. That means this end gets soluble in water. So we will say it is soluble in water. Imagine such a small soap molecule, it has also two parts, and that part had so many names. I can say that this part which contains sodium or potassium ion is called as hydrophilic end of the soap molecule, also called as polar end. Pole means it is formed by the sodium or potassium salts. This hydrophilic end is soluble in water. Philic means water loving. So it is soluble in water. Now the other end which we are talking about, this is a non-polar end, is the organic part. From the definition we can say of fatty acid, sodium salt of fatty acid. So this fatty acid is present at the non-polar end. It is also called as hydrophobic end. Now what is hydro means water, phobic means to get fear of something. Phobia is I am scared of something, I am scared of height. Now this word phobia is fear. Here the word is used to show that it is insoluble in water. That means it is not loving water. Now here it is water loving part, but here it is not loving water. Now that two parts of the soap molecule, one is hydrophilic end, one is hydrophobic end. Hydrophilic end contains sodium or potassium salt, and hydrophilic end is the organic part, that is the fatty acid part. Now if one molecule is like this, all the molecules of soap, how they will attack on the dirt. Now let us show. Now let's consider that I am attacking, number of soap molecules are attacking the dirt on your shirt or on your cloth. What will happen? This dirt is organic in nature. Why it is organic in nature? Because when we are using clothes, we are also sweating out. The sweat which comes out of our body contains salts, and those salts can have organic part in it, and those salts attract the dirt. So once I put the cloth in water, I might remove the dirt part. The dirty part can be removed by water, but what about the organic part which has come and got stuck on my cloth? So that organic part has to be removed. So what happens? Suppose consider this is a dirt molecule. Okay, it is greasy in nature. Why greasy? As I said, a lot of sweat is coming, lot of dirt is getting attracted, so it becomes greasy, oil based dirt. So it is called as oil based dirt. Now this dirt part, we are considering one particle of dirt. How the soap molecule is acting on it? Let's see, there are number of soap molecules surrounding it. Now if I have put a cloth in the foam, what will happen? The dirt particles are surrounded by various soap molecules, and hydrophilic end are away from this dirt particle. That means away from the dirt particle. You will find here hydrophilic end or the sodium or potassium part away from the dirt. And this end which is covering the dirt, the other end which is covering the dirt which was made of fatty acid, is trying to remove this greasy part. Now you all know the organic compounds are soluble in organic solvents, not in water. So that is why soap is made in such a way that it is a sodium or potassium salt of fatty acid. This fatty acid is in the solvent form. This solvent form surrounds the dirt and snatches it away from the cloth. Now this dirt has gone into the small pores of the cloth, and through that pores it is snatching it away, trying to remove it. And this formation is called as micelle. Micelle formation. This micelle formation is nothing but the soap molecules surrounding the dirt and trying to remove the dirt from its hydrophobic end. This hydrophobic end acts on the dirt particle, removes it from the pores and comes and gets soluble in water. So what will happen? Does it form a precipitate? No, it will not form precipitate. Have you ever seen lot of precipitate getting accumulated in bucket? Can you ever see? We have never seen that. Why? Because all dirt float on in water. Once they come out of cloth, they do not settle down. They float in water. Why? Because this sodium and this sodium both have positive charges. That means same charges. And same charges repel each other. And this repelling forms them to form colloid instead of precipitate. And they remain in the colloid form. That means colloid form means which can easily float, which does not settle down. And therefore, if we wash the cloth 2 or 3 times with different water, we are removing this dirt very easily. This is the working of soap or detergents on dirt. Very important part is you to know what is micelle formation. Micelle formation, again I am repeating, micelle formation is nothing but surrounding the soap molecule or the detergent molecule is surrounding the dirt. This dirt is removed by the fatty acid part, that is the hydrophobic part, and it floats in water. And this sodium or potassium, if it is potassium, they do not settle down because they are all positively charged, same type of charge is there, it forms a colloid which helps them to float, and thus the dirt is removed from the cloth. This is the working of soap molecule. Now if I ask you, this is general working, but what is the difference between soap and detergent? Now detergent and soap, if I use a normal soap, the washing soap, I'll see that it doesn't work well with hard water. What is hard water and what is soft water? Hard water contains some magnesium and calcium salts, and that does not forms colloid, they form precipitate and they settle down, and that is why they form the insoluble part. Soap does not react properly with hard water because the sodium and potassium salts of fatty acid forms insoluble compounds. With hard water, now I'll tell you, with hard water, soap forms insoluble compounds. Okay, but what about detergents? Detergents are not sodium and potassium salts. They are ammonium and sulfonate salts. What are they? They are called ammonium and sulfonate salts. So detergents are ammonium or sulfonate salts of fatty acids. So what is the difference? The difference is sodium and potassium salts of fatty acids form insoluble compounds with hard water, but ammonium and sulfonate salts form soluble compounds with hard water. They form soluble compounds with hard water. So therefore it is seen that detergents work very good with soft water also and hard water also, but soap is working good with soft water, but with hard water we cannot see the foam which is formed because large amount of insoluble compounds are formed. This is the difference between soap and detergent. Now we saw how soap molecule works on the dirt. Now this was related to cleaning of clothes. Now we are using toilet soaps also. That means we are using so many types of nice perfumed soaps for bathing. What is the difference between those soaps and the laundry soaps? The laundry soaps means the soap which is used for cleaning of the clothes, and toilet soaps here means the soaps which we are using for bathing or cleaning our bodies. And what is the difference? We are going to find out. You can write the difference also between the toilet soap and laundry soap. The first difference is high quality of fatty acids are used here in toilet soaps. That means large amount of very high quality of oil, very high quality of fats is used in making this toilet soaps. What can be the reason for it? Because we are directly using over our skin. We cannot use a very low quality fatty acids, or we cannot use very low quality of any other product which may affect our skin sensitivity. So first point is high quality oils and fats are used. And comparatively, laundry will have cheap quality oils and fats. Second difference major, when we use the bathing soap, you get a nice perfume or nice flavor or nice smell comes. Now what is that smell coming from? Many times you may see the different flowers smell are also put. Various types of essence is used, various type of esters are used. Now in laundry, we don't need such a type of so many flavors in it. So bathing soap will contain expensive perfumes are added, will contain expensive perfumes. Now in this second part here, the laundry soap, expensive perfumes are not used. Only some perfumes may be of lemon or maybe of some nice smelling which may not come in the way of cleaning the clothes. That is why a not very expensive perfume but a cheap perfumes are used. Not much importance is given here for laundries. This is the second difference. Third difference, no free alkali content is present here. The alkali content means, remember I said what is soap? Soap is a sodium or potassium salt of fatty acid. Now that sodium salt is coming from NaOH which is added. So that NaOH do not have any free alkali which may affect our skin. So here third is no free alkali is present in this soap. No free alkali. When I talk about alkali here, while making the soap we make use of KOH or NaOH. So here no free alkali is used. If any amount of more alkali is used, it may affect our skin because our skin is very sensitive. Now here free alkalis are used here. Free alkali are used. Now why here it is used? Because we need that alkali for the cleansing purpose of the clothes. We do not, the clothes are not getting so sensitive like a skin. Therefore here the free alkalis are used for cleaning purpose, but here no free alkalis are present in this type of soap which may be harmful to your sensitive skin. So these were the differences between two types of soaps which we use in our daily lives. So students, we have gone through the whole chapter of carbon compounds. We have gone through its versatile nature, where is carbon formed, how many types of carbon compounds are possible, what is its nature, how its valency tries to satisfy itself by forming covalent bonds. What are the various types of organic compounds? What type of reactions they form? All this we have gone through. I have tried to explain you each and everything from your book. Let's have a concept map and we will try to understand in short about the whole lesson. Now this is a concept map. We have substances in nature. There are many types of substances which are present in nature. In nature, these substances can be from natural or it can be non-living things. When I say natural, that means if it is plant origin or animal origin. So that means they are under living things. Some substances in nature are non-living things. Those non-living things are further used as inorganic chemistry. Now animals and plants which come under living things, they are known as organic, or we study them under organic chemistry. These organic compounds can be converted into inorganic compounds also. So till now what we have understood that substances which are present in nature can be of two types, living things and non-living things. If they are living things, they are called as organic compounds, and if they are non-living things, they come under inorganic compounds. Organic compounds can be converted into inorganic compounds also. Now organic compounds we study mainly are two types, saturated compounds and unsaturated compounds. Now what were saturated compounds? Saturated compounds were the compounds which had only single bond in them. So the compounds which are saturated, they have single bonds. Example is alkanes. Can you recollect what are alkanes? I'll tell you the examples of alkanes: methane, ethane, propane, butane, pentane, hexane. These are the series which are coming under alkanes. They contain only single bond in them. Another type of organic compound is unsaturated compounds. Unsaturated compounds, what are they? Think. They are the compounds which contain two bonds or double bonds or three bonds or triple bonds. So if the compound is having double bond or triple bond, they are coming under unsaturated compounds. For example, alkenes and alkynes. Alkenes are the compounds which contain double bond, and alkynes are the compound which contain triple bonds. You can see the difference in the spellings. There is only one letter spelling difference. Alkanes had ANE, alkenes have ENE, and alkynes have YNE. While I was explaining you, I had told you the differences between them. Saturated compounds or alkanes, they show substitution reaction. Now what was substitution reaction? When you substitute a thing from another thing, that means another thing is taking the place of the original substance. So these are the saturated compounds show substitution reaction. Unsaturated alkenes and alkynes in the IUPAC system, they are the fundamental parent compounds. So we have to first find out which is a parent compound, and then we name them or we give the nomenclature. What is IUPAC? The organic compounds can be named by IUPAC system. IUPAC, International Union of Pure and Applied Chemistry. So this is IUPAC system. Unsaturated compounds show another type of reaction which is called addition reaction. While I was explaining, I explained you how addition can be taken place. What is addition? When we add another molecule, the double bond is broken or triple bond is broken and it converts into alkanes. Example was hydrogenation of oils into ghee. So this is just an outline of nature of organic compounds and inorganic compounds. We have highlighted the various characteristic features of organic compound in this chapter. That's why we gave the name of this chapter was Amazing World of Carbon Compounds. If you know this concept map, it is very easy for you to go through the chapter step by step. Now we can discuss the exercise of the lesson on page number 114 or 114. Please take out the exercise. We will discuss the questions one by one.